So here's my problem for you today. Go ahead and identify all the shapes and put them together. Go.
Oh, I get it. 1, 2, 3, 4, 1, 2, 3.
Answer?
8 circles or 6 triangles?
Okay, so all of a sudden you tell me this. 8 circles, 6 triangles, right?
Yeah.
Clearly you are grouping them. Why did you decide to group all the circles together? What do they have in common?
The colors and the shape.
The colors and the
Shape.
shapes. Just like you have the triangles, right?
Yeah.
And so we learned that technique long ago, and then when we get to math, all of a sudden you just forgot all about it. I don't know why. But we are doing the exact same thing today. By looking at what do we have in common? For example, if I translate that back now into a mathematical expression, for example, 6a minus 4b plus 8a plus 8b, for example, can you do that? What does say combine them? Look for commonality. Do we see anything in common?
Yes.
Yeah, what are they?
8A and 6A.
Okay, so you say 8a and 6a because
Because they
they all have a's, right? Just like how we identify the shapes because of certain characteristics. And now when we bring it back to our math, we look for the variable because the variables will tell us whether or not they are same terms, like terms. So then you basically say this, oh yeah, because they're both ends in A, we know they are like terms. Just like how the B is, they both ends in B. And that's how we know they are alike. And when we did this before, when we start boxing and circling the terms to identify what alike. And then when I say combine like terms, all of a sudden people got stuck. It's like, combining? What do you mean by combining? Meaning putting them together. Can you? What is 6a and 8a combined to be? 14, what? A. And you know what some student did? They multiplied. Even after I said combine like terms. Combining. You know, I'm pretty sure when your parents say something like, can you combine those two together? I don't think they meant multiplying, right? Or dividing. Is that true? Meaning just put them together. It's just like count them up, basically. So I'm trying to put it in simple terms so you understand what I'm saying. What about the B's? Negative 4B's, you said?
Positive 4B.
Positive 4B. And that's it. And the reason I cannot combine like anymore is because A's and B's are different terms, just like how you have 14 circles and 4 triangles. Those are just separate things, and I cannot combine them. I try the best that I can, and that's what I came up with. Questions? Okay, so we learned how to do this before too. Combine like term with variables, and all of a sudden today, of course, we started with radical yesterday, and I want you to go ahead and apply that same technique, starting with the shapes, then with the variables, and now with the radicals. Do you see any like terms?
Yeah.
Look carefully.
14,
13 and 11.
13 and
Can you recognize like terms when you see
13
it?
and 11.
What is it?
13 and 11.
Okay, so what would you, let's just start boxing and circling. What would you circle?
14, negative 14, 13.
Okay, so you circle that one. What else would you circle?
6.
Very good. Okay, what else would you box in?
15, radical 11.
negative 11.
Negative 11, radical 11.
There it is. So, we've moved from kinder with shapes identifications to a little bit after one with variable identifications. Now, we'll end with radicants. That means what? How do we know if these are the same? If they have the same radicants. That's how we know they are like terms. Remember the radicand is inside of the radical sign? And the reason we circle the negative 14 to 6 because they both end in 13 as a radicand. The same thing as 11 here, negative 11 and positive 15. They both end with radical 11, right? So now we are treating the radicands like variables, just like shapes. You can call this as, oh, I have negative 14 circles, and this is 6 circles, and this is negative 11 rectangles, this is 15 rectangles. You can certainly replace that radicand with some kind of terms to kind of remind you that they are like terms. But if they are like terms, do we do anything with that identification of like the root 11, for example? Do we actually add them together? Think about that. Just like how I asked 6a and 4a, do we actually do anything with the a?
No.
No, right? It's just 10a. We simply combine like term using the coefficient that we have. So for example, if I start combining and putting them together, what do you have here for the radical 11?
4.
Exactly. 4 what?
Radical 11.
There. Because that is our identification of like terms. I just put radical 11 terms together. See it? Okay. Please ask questions now because I don't want you to get this mixed up again. What else can we combine?
Negative 14.
Which is?
Negative 8.
8 what?
Negative
And radical 13.
There it is. And that's how we do it. Question. Can we simplify some more?
Yes. Wait.
No.
Are you sure?
Yeah.
I'm talking like now that we cannot break down the radicand, can we do GCF now?
Yeah.
See? We can have 4 and negative 8. What can we take outside?
Negative 4.
4. If we take out the 4, what do we have left inside? 1 root 11, right?
Yeah.
And here?
2.
There it is. Outside with outside, inside with inside. We don't mix it up, right? But that's what we have. If the radical inside have something in common like GCF, we certainly do that too. But in this case, 11, 13, they're both prime. Can't take anything out. We'll get to a case where we can actually do both. But there it is. We can certainly simplify it that way. Okay, until we cannot do anything anymore. Okay, question on that particular problem? No? Feel free to voice your concerns because, you know, as we move on, I need you to make sure you understand this. So here's the next thing. I ask, are you sure what our difference is? Can we work it out? Okay, so far this is what we see. We see like terms. No? Can't work it out? Or we'll try to make it work, okay? So apparently, before we have like radical with the bracket inside the same, then we can certainly combine them. What if we have a case like this where I have 3 root 2, and over here I have 2 root 8, for example. And you say, and I ask you to combine like terms, and you look at it and you're like terms? I don't see anything like terms here. The radicands are exactly, they're not the same. You can't combine them, right? But please look carefully again. Are we done everything we can to make it put it in the simplest form?
No.
See, the answer is no. So until you have exhausted all options, just like you tried everything you can to make it work, don't give up yet. Okay? So here, it seems like 2 is good. We're done. There's nothing we can do. But look at the 8 though. Can we break that down?
2 times 2.
Okay, so for at least for this one right here, we know that when we break down the 8, we have 2 times 2 times 2, right?
4.
And then we can take what outside?
2.
Just the 2, because we found that pair, right? The twins. We take that outside,
4.
and what will the outside become?
4.
4. This is 4, and the inside will remain as a 2. Look at that. And then we can certainly move this down. We have 3 root 2 minus. Now, can we combine like terms?
Yes.
See that? So what's our final answer going to be?
Negative 1 over radical 2.
That's it. Or you can certainly write it as negative root 2. It's the same thing. Remember, if I don't have a number in front, it's automatically at 1 anyway. Because that's easy to work on. So, if you first look at it and they don't look the same to you, don't say, oh yeah, I can't combine like terms. Not until you've tried everything. Okay? So with that in mind, let's go and try this one. Don't forget, until you have exhausted every option, do not give up on it. So as we resume here, you clearly see that for 12, why am I getting that there? For root 12, you break it down, what do you have?
3 times 2 times 2.
Yes, so 3 times 2 times 2. There. So I just go ahead and break each one down. For 6, 48, what do you have?
3 times 2 times 2 times 2.
Okay, so 3 times 2, that's 6, and then 8 is 2 times 2 times 2. Agree?
Yep.
424.
3 times
3 times 2 is 6, and it times 4, which is 2 times 2. There. Any problem doing that?
No.
I think this is like number one reason where students kind of give up on it, because I can't break it down. Remember, we have several ways to do this, right? Either doing a factor tree or a factor ladder. I know we'll take some time to work on it, but hey, better be safe than sorry, right? You see a pair here.
Yeah.
Right there. There it is. Cross it out. That means I have how many 2's outside?
1.
1. So the outside going to become
8.
8 root 3. Question there. Next one. How many pairs?
2.
2 pairs. So that means outside I have
24.
4 outside. Bringing out 4, and then 6 times 4 is 24. Root 3 inside. Last one.
1 pair.
1 pair. So I have what outside?
2. 10.
10, right? Root 6. See that? Now can we combine like terms?
Yep.
Okay. We clearly see that these are like terms. And they all end in root 3, so I can put them together. What is 8 minus 24? Negative 16 root 3. Notice that like terms stay the same as like term. We don't do anything with radican, right? And then the other one is 10 root 6. Okay? Now, of course, if you're happy at this stage, which is good, I mean, you're getting almost to the end. But can we still factor out GCF?
Yes.
What can we take out?
Negative 2.
Negative 2. Okay, you said negative 2. So let's take out negative 2. If I take out negative 2, I will have 8 in here, root 3. And here's what? Minus 5, root 6, right? Okay, so we took care of the outside number. Agree? But don't forget, remember how we treat outside and inside separately? Look at the inside. This is root 3. This is root 6. Do we have GCF for 3 and 6? 3. So that means I can certainly take out a root 3. If I take out root 3, that means there's nothing left here, right? Just 1. So it's good. 8 has to remain. Over here, what do you have left? Root what?
2.
Root 2. Because 3 times 2 is root 6. There it is. So you can see I go through several steps, but that's how you would factor it at the end. Of course, you simplify the radical, and then at the end, if you have GCF to take out a GCF as well. Okay? But this is how it works. Question on this? Let me know. Okay? Alright. So as we go on to this one right here, try to remind you of a boxing. Boxing, anyone? You remember what we used the box for?
Yeah.
What?
To fight.
To what? Factor.
Factor.
To factor or?
Find the simplify. No. To
What is that? What is it? Okay, factor means we factor out, right?
Yeah.
What do we do when we do inward? We factor out. We are doing what? When we see when we start factoring, we fill in the box. We factor out. But what if the box are blank? What do we fill outside? What are we doing?
Oh, multiply.
Yeah, multiplying. There it is. Okay, and so let's just go and remind you about that again. Remember when we used to do this here? Remember that?
Yeah.
Let's do that. How do we set this up?
put A
2 by
box
2.
Box it.
2
How
by
many?
2.
What size of the box?
2.
It's 2 by 2. Okay.
A plus or A and
AB, right? And 2A minus B. Agree?
Yeah.
Okay. So let's multiply. What do you have?
2A squared.
2A squared.
2A
2AB
AB negative
minus AB and
Plus
negative
B squared.
B squared. Do we see like terms?
Yes.
Yes.
Right here. So we can certainly put them all together. Write it out first if you want. Let's write it out. A squared plus 2AB minus AB minus B squared. These are like terms, so if you simplify that, you simply have 1AB left. This is how we used to do it, right? The box. So technically it's the same kind of deal. And I want to remind you about that again because when it comes to radicals, we can still use the box. What size is this? What size box do you think we could use?
2 by 2.
It's a 2 by 2 again,
Yeah.
right? So if you're going to be using a 2 by 2 box on this, what do we fill out on the outside of the box?
6 radical 7.
Okay, let's do that. 6 radical 7,
And 3 radical 7.
3 rad 2,
And 4 radical 7.
4 rad 10.
And
Negative 5
radical
root 6.
Okay, can you do that? Okay, so we got the box set up. can you multiply? See? This is the question where a student's gonna get confused on. Okay, I don't know how to multiply now. All of a sudden, because I set it up like this, you forgot all about the outside with outside, inside with inside. Right? Still, we are applying the same exact strategy. What is the inside going to be?
24 root
24.
70.
Yeah, 24 rad 70. There. Is that hard?
No.
Next.
12 radical 20.
Rad 20. Okay, here's the thing that we need to do also as we work on each box. Maybe you should create a bigger box. Here's the reason why. Do you realize that sometime inside this radical sign, we can actually take out twins, right? If we can actually take out twins, we should do it. For example, rad 70. Can we take out twins there?
10.
We break down to 70, what do you have? Well, actually, you can certainly, you know what, if you want to multiply that first, fine, and we'll take care of it later. Let's multiply first then. What do you get? Here. Negative 30, rad 42. And over here?
Negative 15. Rad 12.
Rad 12. Okay. See that? And then I'm going to go ahead and write it out. I have 24 rad 70 plus 12 rad 20 minus 30 rad 42 minus 15 rad 12. Okay. Any question what I just did? I'm simply multiplying and then just write everything out. But don't forget, remember we need to work out our differences if we can, right? Meaning, if they don't look alike at first, see if we can actually break it down and pull out some twins and we'll see if it's going to change anything. So let's take a look at rad 70. If you break down 70, don't you have 10 times 7?
Yeah.
But we know that 10 is 2 times 5. And 7 is just 7. And clearly, there's nothing here that you can pull out. So this will stay as is. Agree? Move on to 20. If you break down 20, what do you have?
10 times 2.
2.
See, instead of saying 10 times 2, can you do like 4 times 5? Right?
2 times
But-
6
but-
is 5.
But you know it works still.
5, 2, 2.
So 5, 2, 2. Do we see a pair?
Yeah.
We do this time. So that means we pull that outside. And what do we have outside here?
24.
24 rad
5.
5. Moving on to 42. If we break down 42, we have 6 times 7. And 6 times 7 is 2 times 3. So 2, 3, 7, anything?
No.
No. So that will remain as is. What about the 12?
3, 2, 2. 3 times 2.
3, 2, 2. 2, 2, 3, right? Do we see a pair here?
Yes.
We do. We take it outside, and what do we have?
Negative 30 over
Rad
rad 3.
Not over, but rad 3. Okay, so we try our best, right? We look at this right here carefully enough and say, wait, can we combine like terms anyhow?
Yeah.
Anything like terms?
No.
No, nothing. How about GCF? Any GCF to take out? Look at the outside first. Any GCF for the outside? You have 24 and 30.
6.
6. Okay, so we pull out 6. That means we'll have,
4.
what, 4
Four.
rad 70.
Uh,
4 again, right?
Yeah.
And what about this?
Negative 5.
Negative 5 rad 42. Negative 5 rad 3. And I took at the outside. Let's take a look at the inside. I have 75, 42, 3. No GCF for the inside, so we're done. That's it. We're good. Is it? Okay. What do you think of that? I mean, it can be lengthy, but it's definitely doable. As far as setting up the box and try to simplify as much as you can, combine like terms. Okay. All right. So I think we're down to the last thing here. And this is called the conjugate. What?
Conjunction.
Conjugate. No, it's not conjunction. Conjunction. No. It's actually the conjugate. Stand for the conjugate.
Conjugate.
Conjugate. Conjugate when you use it as a verb and conjugate as a noun. So in this case, we're using it as a noun. So the conjugate. Conjugate. Okay. So, what is the conjugate, you might ask? Okay. Let me introduce to you what it is anyway. It starts kind of like way back. Let me just try to remind you about this here. But the reason we want to find a conjugate is for a very good reason. Let me give you a good example here. Remember when we used to have something like this? Remember that one? If we were going to do a box on it, it's a 2 by 2, right? Clearly. But there's a special characteristic on this, and I hope you are reminded of something. What does this remind you of? The box I know, but dots. Dots, right? Because if you do a box on it for real, 2 minus b, 2b, that's just 4. This is negative 2b, this is positive 2b, and this is negative b squared. So essentially, the middle term gets canceled. Remember, dots is a 2 term, no middle term, and the reason for that is because, look at the 2 terms. They're exactly the same except for the middle is opposite of each other. And you know opposite sign will get canceled.
Yeah.
Okay? And so when we really expand it out, we just have to worry about the first 2 and the last 2. So it's like you just multiplying 2 times 2 is 4, and negative b times b is negative b squared. And that's exactly what we have when we do the box for it. Okay? But when you look at the 2 factor here, one is conjugate of the other, meaning they're exactly opposite of it. Okay? So if I say, oh yeah, if I give you 2 plus b and I ask you to find its conjugate,
2 minus
then you say it's 2 minus b. Or vice versa, if I say, what if I give you 2 minus b? What is the conjugate of that?
2 minus b.
2 plus b. Has to be the opposite sign. Try another one. If I ask you to find a conjugate of, for example, that, what is the conjugate going to be? Very good. 3 minus rad 2. You see how that works? So let's try another one. What if I give you the conjugate of, if I give you 5 minus 2 rad 2, what's the conjugate of that?
I said it first.
Okay. Is that hard to do when I say find a conjugate? Okay, now, why is it that we have to find a conjugate? Let me show you why. Remember, when we have the conjugate and multiply it, the middle term will always be what? Cancel. Meaning, all we have to do is worry about multiplying the first 2 and the last 2. So think about this. If we multiply just the first 2, what do we get? 9. The last 2? Minus 2. Because rad 2 times rad 2 is rad 4. Rad 4 is 2. And 9 minus 2 is 7. You see it? Over here. What is this going to get us? 5. What about over here?
2.
Negative 8. How did she get that? Look at this. First of all, what is negative 2 times 2? That's negative 4, right?
Yeah.
And then the inside here will give you another 2, right? That's why it's this. And so that's how you got your negative 8. You see how it works? We still take care of the outside, inside. Okay, if you can't catch that, I'll just do it slowly. Look, a negative 2 times the 2 is a negative 4 outside, and inside is a 4. But clearly, you can take out the twins here outside, which is a 2, and that's how we got the negative 4 times 2 outside. And that ends up being a negative 3. Clear about the conjugate?
Yeah.
Good, because if you clear on it, then I can just go and show you this last thing, which is pretty straightforward. Notice that I have a fraction, right?
Yeah.
10 over root 7 plus root 2. But remember I told you that we can never allow to have the radical in the bottom?
Yeah.
Never ever?
Yeah.
And before, when we only have like one term in the bottom, we just have to multiply that same term by the radical, its own radical, to clear it. But here, if we have multiple terms, in this case, exactly 2 terms, the only way to clear it is by multiplying these 2 terms by its conjugate. So, you can ask yourself this question. What is the conjugate of what I just parenthesized?
Rad was 7
Rad 7
minus 2.
minus rad 2. That's it. But remember, if we multiply the bottom, we have to multiply the top as well. So the top will get the same exact thing. There it is. See it? So let's take care of the top. What do you do with the 10 here? What are you doing? Remember, we're multiplying, so what is the 10 going to be doing? Distributing. That's 10 times that, right? So you distribute that. What do you have?
10.
7.
10.
Okay. Bottom. Oh, now this is the easy part because we know it's their conjugate, right?
Yeah.
So what's the bottom to be? 7. That's it. See it? Clear? Okay. We know the bottom is 5, but look at the top. Can we factor out something? 10. We take out 10. What do you have left inside? And look. What is 10 over 5 going to be?
2.
2. So 2
2 minus 7.
Root 7 minus root 2. And that's our simplified answers. So notice we no longer have our radical in the bottom. We were able to rationalize it. And with two terms like this, we rationalized by multiplying it by its conjugate. Okay? Just pop a conjugate before, and that's it, guys.
Can I do that by memory?